In the quiet dawn of the 20th century, a new mystery began to unfold, one that would challenge every idea humanity held about reality itself. The air was thick with curiosity, and the minds of the greatest scientists were restless. They believed they had nearly solved the puzzle of the universe. The laws of Newton, the equations of Maxwell, and the discoveries of Einstein had painted a picture of a world that was rational, predictable, and complete. To them, the universe was like a perfect clock. Every gear in motion, every second accounted for, every movement explainable. But beneath that calm mechanical surface, something strange was stirring. Deep within the atom, hidden beyond the reach of ordinary observation, nature behaved in ways no one could predict. The closer scientists looked, the less sense things began to make. It was as if the universe itself resisted being pinned down, as if reality refused to be caged by certainty. And from this chaos, a young physicist named Werner Heisenberg would emerge, armed with a mind sharp enough to pierce the fog of confusion that surrounded the quantum world. Heisenberg's journey toward uncovering the revolutionary idea of uncertainty was not a straight path. It was born out of frustration, sleepless nights, and a burning desire to understand what the equations of the atom were trying to say. The early 1920s were a time of scientific rebellion. The old world of classical physics was falling apart, replaced by strange new theories that defied logic. Atoms did not behave like tiny planets orbiting a sun, as Bohr's model once suggested. Instead, they seemed to vibrate, disappear, and reappear in patterns of pure probability. Imagine Heisenberg standing at a blackboard late at night in Göttingen, Germany. Chalk dust hangs in the air like mist. Equations stretch across the board, symbols of hope and confusion. Outside, the world sleeps, but inside the young scientist's mind, reality itself is being questioned. Heisenberg wanted to find a mathematical description of how electrons move around the nucleus. Yet every attempt to track their position and speed led to contradictions. The more precisely he tried to define where an electron was, the less he could say about how fast it was moving. It was as though the universe was whispering to him a secret. Knowledge itself has a boundary. Heisenberg began to realize that the problem was not in his equations, but in the very nature of measurement. The act of observing a particle was not passive, it was intrusive. When a scientist tried to observe an electron's position, the light used to see it disturbed it, changing its motion. The simple act of looking altered the thing being looked at. This was not just a limitation of technology, it was a limit written into the fabric of the cosmos. As Heisenberg's ideas evolved, he started to see the universe in a completely different way. Reality was no longer a fixed stage where events unfolded. It was a dynamic process of possibilities. The particle was not a solid object moving through space. It was a cloud of potential, a wave of probability that only became real when observed. This was a radical idea, one that tore apart centuries of scientific tradition. The notion of uncertainty was not just a minor correction to physics, it was a revolution. Heisenberg's discovery challenged the very core of how we think about knowledge. The world was no longer something that could be fully known or controlled. Instead, it was a mysterious interplay between what exists and what can be observed. Nature, in its smallest form, was unpredictable, fluid, and alive with chance. The power of Heisenberg's insight lay in its simplicity. He expressed it through a single mathematical inequality. Dx multiplied by p is greater than or equal to h divided by 4i. This small equation captured the essence of uncertainty. The more precisely you know a particle's positions at dx, the less precisely you can know its momentum off, and vice versa. The letter stood for Planck's constant, the heartbeat of quantum mechanics, the smallest possible unit of action in the universe. With this elegant expression, Heisenberg showed that the limits of measurement were not about human imperfection, they were built into nature itself. In the halls of science, this revelation caused an earthquake. Many physicists refused to accept it. How could the universe be uncertain? How could reality depend on observation? For centuries, science had promised absolute answers, precise predictions, and complete understanding. Now, one young man was saying that uncertainty was not an error, it was truth. Einstein himself struggled with the idea, famously declaring, "God does not play dice with the universe." But Heisenberg, calm and confident, believed that perhaps God did play dice, and that the dice were quantum in nature. This new quantum reality changed not just physics but philosophy. It forced humanity to rethink what it meant to know something. If observation changes the observed, then every act of measurement becomes a dialogue with the universe. The observer is no longer separate from nature, he or she is a participant in its unfolding. In this vision, reality is not a fixed structure waiting to be discovered. It is a living process that takes shape through interaction. Heisenberg's uncertainty principle became a mirror reflecting the limits of human knowledge. It reminded scientists that even with all their instruments, formulas, and theories, there would always be a veil they could not lift. The quantum world refused to be pinned down because it was built on probabilities, not certainties. And yet, within this unpredictability, there was order, a deeper harmony hidden in the mathematics of waves and energy levels. As the principle spread across the scientific community, it began to influence more than just physics. Philosophers saw in it a reflection of human consciousness itself. Artists and writers found beauty in its paradox. Certainty born of uncertainty, order born of chaos. The world suddenly seemed more mysterious, more alive, more connected. Heisenberg's revolutionary idea was not just about particles, it was about perception. It suggested that what we call reality is shaped by how we choose to observe it. Each experiment, each observation, brings a new version of reality into being. The line between the observer and the observed dissolves, and the universe becomes a dance between possibility and perception. Imagine the world through Heisenberg's eyes, a universe not of rigid objects, but of shimmering possibilities. Each particle a note in an infinite symphony, each observation a choice that changes the melody. The more deeply he studied the quantum realm, the more he realized that reality was not a static picture, but a living process, vibrant and uncertain. This was not an easy truth for the world to accept. In lecture halls across Europe, scientists debated passionately. Was Heisenberg's principle a sign that physics had failed, or was it a glimpse into a deeper layer of truth? Some believed that uncertainty meant the end of science, that if we could not know everything precisely, then knowledge itself was lost. But Heisenberg saw it differently. To him, uncertainty was not a wall, it was a window into the strange, creative heart of the universe. Heisenberg's insight would go on to inspire the development of quantum mechanics as we know it today. It became one of the cornerstones of modern physics, guiding the work of scientists who built quantum theory into the foundation of modern technology. From atomic energy to quantum computers, from semiconductors to lasers, the ripple of his discovery spread through every corner of human advancement. But beyond the laboratories and the equations, there was something more profound. The uncertainty principle carried a lesson about life itself. Just as we cannot know both position and momentum with perfect accuracy, we cannot predict every detail of our own paths. The future is not a fixed destination, it is a landscape of probabilities waiting to be shaped by our choices. Heisenberg's world of uncertainty mirrors our own existence. Every decision we make, every dream we pursue, collapses one possibility into another. We are the observers of our own quantum reality, forever caught between what is and what could be. And in that delicate balance lies the essence of human experience. The beauty of not knowing, the thrill of discovery, the mystery that gives life its meaning. As the decades passed, Heisenberg's revolutionary idea became a cornerstone of modern thought. It continues to inspire scientists, philosophers, and dreamers alike. The uncertainty principle is no longer just a scientific statement. It is a poetic truth about the nature of existence. It teaches that the universe is not cold or mechanical, but alive with mystery and motion. Werner Heisenberg's insight did not close the book on physics. It opened a new one. It invited us to look beyond the surface, to embrace the unknown, and to find beauty in the limits of knowledge. His idea of uncertainty did not destroy reality, it deepened it. It showed that within the very heart of unpredictability lies the pulse of creation itself. And so, as the camera fades on the image of the young scientist staring at his chalkboard, we are left with a haunting realization. The universe is not something we merely study, it is something we are part of. We are woven into its uncertainty, its mystery, its dance of chance and choice. Heisenberg's revolutionary idea of uncertainty in quantum physics did more than change science. It changed the way humanity understands existence. It told us that in every flicker of an electron, in every breath of energy, lies a secret, that the world is not made of certainties, but of infinite possibilities, waiting to be observed, waiting to be imagined, waiting to become real. The story of Heisenberg's uncertainty principle did not end with its discovery. It was only the beginning. The young physicist had opened a door that no one could close, a door that led directly into the heart of reality itself. But beyond that door lay confusion, resistance, and wonder. The scientific world was divided, struggling to make sense of what this new idea truly meant. For centuries, science had been a march toward certainty, toward precision and control. Now, one simple principle had told them that certainty was an illusion. The universe, it seemed, was not bound by the straight lines of human logic. It moved in waves, probabilities, and shadows. Heisenberg's theory grew like a spark into a wildfire of questions. What does it mean to know something if our act of knowing changes it? What is reality if it depends on how we look at it? These questions spread far beyond physics. They touched philosophy, art, and even human identity. The principle of uncertainty was no longer just about electrons, it was about existence itself. In the years following 1927, the young Heisenberg found himself surrounded by a circle of the brightest minds on Earth: Niels Bohr, Max Born, Erwin Schrödinger, and Albert Einstein. Together they debated the meaning of the quantum world. These were not quiet academic arguments, they were passionate battles of ideas, echoing across the lecture halls of Europe. At the center of these debates was a single, unsettling truth: the universe, at its most fundamental level, does not behave like the world we see. In the realm of the very small, particles act like waves, and waves act like particles. Things can exist in more than one place at once. An event can be both true and false until it is measured. This was not science as people knew it. It was a kind of poetry written in mathematics. Heisenberg's uncertainty principle became the key to unlocking this strange poetry. It explained why electrons could not have fixed paths around the nucleus. Instead of neat orbits, as in classical models, they existed in blurry clouds of probability. These clouds represented where an electron might be found, not where it is. The quantum world was a world of maybes, a universe of possibilities waiting for observation to collapse them into reality. But Heisenberg's principle also brought something even more profound: a shift in the human relationship with knowledge itself. For thousands of years, science had been built on the assumption that the universe was an objective reality, existing independently of human observation. Heisenberg shattered that illusion. In the quantum world, the observer could no longer stand outside the experiment. To look was to touch, to measure was to alter. The scientist was part of the very system being studied. This realization was both thrilling and unsettling. It meant that reality was not something separate from us, it was something that happened through us. The act of observation, the very question we ask of nature, helps decide the answer we receive. The universe, in its smallest form, seems to respond to our curiosity. Imagine a lab in Copenhagen in the late 1920s. Niels Bohr and Werner Heisenberg are sitting across from each other, deep in conversation. A lamp flickers on the desk. The air is heavy with smoke and thought. Bohr, ever the philosopher, argues that reality does not exist until it is observed. Heisenberg nods slowly, his mind racing between equations and meaning. They are no longer just scientists. They are explorers at the edge of reality, peering into a world that defies reason. Heisenberg once wrote that what we observe is not nature itself, but nature exposed to our method of questioning. This idea captured the spirit of the quantum revolution. The observer and the observed are two sides of the same coin. The moment we look, the universe decides how to respond. Einstein, however, was not convinced. For him, physics had to describe a reality that existed independently of observation. He could not accept that God would play dice with the universe. To Einstein, uncertainty was a sign of incomplete knowledge, not a fundamental truth. But Heisenberg stood firm. He believed that uncertainty was not a flaw but a feature, a message from the universe that the microscopic world operated by different rules. As the debate raged on, the implications of the uncertainty principle began to ripple through every corner of science. Quantum mechanics evolved rapidly, powered by Heisenberg's matrix mechanics and Schrödinger's wave equations. These theories, though expressed in different languages of mathematics, described the same reality, a universe where probabilities ruled and certainty was an illusion. But beyond the equations lay a deep philosophical question. What is reality, truly? If a particle exists as a wave of probability until observed, then does the act of observation create reality? Are we, in some sense, co-creators of the universe we inhabit? Such questions transformed Heisenberg's principle from a scientific concept into a profound meditation on existence itself. In the decades that followed, scientists began to test these ideas with experiments that seemed to border on science fiction. In the famous double-slit experiment, particles of light, or electrons, were fired through two narrow openings. When unobserved, they behaved like waves, creating an interference pattern on a screen, as if they passed through both slits at once. But when measured, when someone tried to see which slit they passed through, the interference pattern vanished. The particles behaved like solid objects, choosing one path or the other. It was as if the universe changed its behavior the moment it realized it was being watched. This experiment remains one of the most haunting demonstrations of the uncertainty principle. It tells us that observation shapes outcome, that reality and consciousness are intertwined in ways we still do not fully understand. Every measurement collapses infinite possibilities into a single truth. Before that moment, the universe is a sea of maybes, alive, fluid, uncertain. Heisenberg's discovery also reshaped technology in ways even he could not have imagined. The principles of quantum mechanics laid the foundation for transistors, lasers, nuclear energy, and the digital revolution. Every computer chip, every smartphone, every MRI machine owes its existence to the understanding of the uncertain quantum world. What began as a philosophical problem became the driving force of the modern age. Yet, despite its success, uncertainty continues to humble science. Even today, physicists struggle to unite quantum mechanics with Einstein's theory of relativity. The universe, it seems, resists being captured by a single framework. Heisenberg's insight serves as a constant reminder that there are limits to what can be known, and within those limits lies the mystery that keeps human curiosity alive. In the twilight of his life, Heisenberg reflected on the strange journey his principle had taken him on. He realized that uncertainty was not just about the behavior of particles, it was about the human condition. Life itself is uncertain. Every choice we make, every path we take, is guided not by certainty but by possibility. Just as in the quantum world, our futures exist as waves of potential until we act, until we observe, until we decide. Heisenberg's vision painted the universe not as a machine but as a living mystery, a grand experiment in creation and perception. Each observation, each thought, each question becomes a brushstroke in the cosmic canvas, and within that art of uncertainty lies beauty beyond measure. As the decades turned to centuries, the uncertainty principle continued to shape human imagination. Writers, poets, and filmmakers drew inspiration from its paradox. It became a metaphor for love, destiny, and the fragility of truth. The idea that nothing is truly fixed, that everything is in motion, waiting to be seen, resonated with the human soul. In classrooms around the world, Students now learn the simple equation of uncertainty, but few realize the philosophical depth behind it. That tiny inequality, exterpetus e forive, carries within it the entire weight of the quantum revolution. It reminds us that knowledge and mystery are not enemies, they are partners in the dance of discovery. Heisenberg's legacy continues to live on in every scientist who looks beyond the obvious, in every thinker who dares to question the nature of reality. The uncertainty principle has become a symbol of humility, a reminder that no matter how far we go, there will always be horizons we cannot cross. But within those horizons, within that uncertainty, lies freedom. The freedom to explore, to imagine, to wonder. In a way, Heisenberg gave us permission to be uncertain, to accept that not knowing is not failure, but the beginning of wisdom. The same principle that governs the motion of electrons governs the unfolding of our lives. The future is uncertain, but it is filled with infinite potential. Picture again that young physicist in his dimly lit lab in Gallardingen. The chalk squeaks against the board. The equations spill like constellations across the black surface. Outside, the wind moves softly through the trees. In that quiet moment, Werner Heisenberg steps beyond the known world and glimpses something timeless, a truth hidden in the heart of nature. He smiles, perhaps realizing that he has not only discovered a law of physics, but revealed something far greater, that the universe is a living mystery, and uncertainty is its language. Today, as we look deeper into the cosmos, building machines that probe the tiniest particles and the farthest galaxies, we are still guided by Heisenberg's light. His principle whispers through every discovery that knowledge has limits, but imagination does not. That the more we learn, the more we realize how much remains unknown. The uncertainty principle stands as one of the greatest triumphs of human thought. A bridge between science and philosophy, between reason and wonder. It tells us that truth is not a single point, but a spectrum, and that within that spectrum lies the heartbeat of the universe. In every flicker of a quantum particle, in every vibration of an atom, in every breath we take, the mystery remains. And perhaps that is how it should be. For if the universe were certain, it would be static, lifeless, predictable. But because it is uncertain, it is alive, forever changing, forever creating, forever inviting us to look closer, to question, to dream. Werner Heisenberg's revolutionary idea was more than a scientific breakthrough. It was a philosophical awakening. It taught us that uncertainty is not the enemy of truth, but its essence. In the shifting sands of probability, in the delicate balance between knowing and not knowing, we find the pulse of reality itself. And as the music fades and the story draws to a close, we are left with a single, profound realization that in the quantum heart of the universe, nothing is fixed, nothing is final, and everything is possible. In the fading light of a summer evening in Würzburg, Germany, a young boy gazed up at the night sky. The stars shimmered like scattered secrets across the darkness, each one a mystery waiting to be solved. His name was Werner Karl Heisenberg, and though he did not yet know it, the curiosity that stirred within him that night would one day change the course of human thought forever. To the world around him, he was an ordinary child, bright, inquisitive, polite. But within his mind burned an extraordinary hunger, a desire to understand the invisible order that governed everything. Werner was born in December 1901 into a family deeply rooted in the intellectual traditions of Germany. His father, August Heisenberg, was a respected professor of Greek philology, a man devoted to the study of ancient texts and languages. His mother, Annie Wecklin, came from an educated family as well, and together they nurtured their son's love for learning. The Heisenberg household was a world of books, music, and philosophical discussion. It was here that young Werner first learned that knowledge was not simply about memorizing facts. It was about searching for truth. From an early age, Werner displayed a sharp and questioning mind. He devoured mathematics and science with an intensity that surprised his teachers. Numbers were not abstract to him, they were alive, pulsing with meaning. Equations, for him, were not just symbols, they were gateways to the hidden structure of the world. But his curiosity did not stop at numbers. He loved philosophy, literature, and music, seeing in all of them patterns that mirrored one another, the harmony of a Bach fugue, the logic of a geometric proof, the rhythm of a well-constructed sentence. As Germany entered the turbulent years of World War I, the world around young Heisenberg began to fracture. Food shortages, political unrest, and the echoes of conflict reached even the quiet streets of Munich, where his family lived. Yet amid the chaos, Werner found refuge in study. He immersed himself in the works of great thinkers, Count Gotham, and the early physicists whose writings hinted at mysteries hidden within matter itself. By the time he reached his teenage years, Heisenberg was already showing the spark of a genius that could not be contained by conventional education. He attended the Maximilians Gymnasium, one of Munich's most prestigious schools, where he excelled not only in mathematics and science, but also in philosophy and the classics. His teachers soon realized that his intellect operated differently. He did not merely repeat what he was taught, he challenged it, questioned it, sought to rebuild it from the ground up. There was a story told by one of his classmates of how, during a geometry lesson, Heisenberg corrected a teacher's proof and offered a more elegant solution on the spot. He was not being arrogant, he was driven by an inner need to make sense of things in their purest form. Even as a boy, he sought the essence beneath the surface, the invisible logic that held reality together. After the war ended, Germany was a nation in ruins, struggling under economic collapse and political upheaval. But for Werner, this was a time of awakening. The chaos of the outside world only deepened his search for meaning. He began to believe that through science, through the language of mathematics and logic, humanity could rebuild its understanding of the universe, even when society itself seemed to crumble. In 1920, at the age of 18, Heisenberg entered the University of Munich. It was here that his true journey began. At the university, he came under the influence of one of the great minds of the time, Arnold Sommerfeld, a pioneering theoretical physicist known for his brilliant insights and his mentorship of young talent. Sommerfeld immediately recognized something exceptional in the young student. Heisenberg's questions were not those of an ordinary undergraduate. They were the questions of someone who was already thinking beyond the limits of known science. Sommerfeld nurtured Heisenberg's potential, encouraging him to dive deeper into the emerging mysteries of atomic theory. It was an exciting but confusing time for physics. The old certainties of classical mechanics, built by Newton, refined by Maxwell, and expanded by Einstein, were being challenged by new discoveries that defied common sense. The atom, once thought to be a solid, indivisible sphere, had been revealed as a complex and dynamic structure filled with energy and motion. In those early university years, Heisenberg found himself captivated by the revolutionary ideas of quantum theory, which had begun to take shape through the work of Max Planck and Niels Bohr. Planck had introduced the concept of the quantum, the idea that energy is not continuous, but comes in discrete packets. Bohr had built upon this, proposing a model of the atom in which electrons orbited the nucleus in quantized energy levels. It was elegant, but incomplete. No one yet fully understood the strange behavior of these subatomic particles. Heisenberg wanted to know more. He wanted to understand not just how atoms behaved, but why. And so he threw himself into his studies with tireless energy. His fellow students would often find him in the library long after midnight, scribbling equations, lost in thought. He was fascinated by the contradictions of quantum theory, the way it both explained and defied logic. There was something beautiful in its uncertainty, something poetic in its refusal to fit neatly into human expectations. But Heisenberg's journey was not without struggle. The world outside academia was changing rapidly. Germany was gripped by economic depression, political turmoil, and social unrest. At times, Heisenberg found himself questioning the purpose of his work. What use was studying atoms when the world was falling apart? Yet he held on to a quiet belief that knowledge itself was a form of hope, that understanding the universe could one day bring order to human chaos. In 1922, Heisenberg traveled to Göttingen, a city that was becoming the beating heart of theoretical physics. There he attended lectures by Max Born, whose work on atomic structure was reshaping the field. Born's mathematical rigor and visionary thinking impressed Heisenberg deeply. Under Born's guidance, he learned to see physics not as a collection of isolated facts, but as a unified framework, a language that could describe the universe with both precision and beauty. It was in Göttingen that Heisenberg's ideas began to crystallize. He immersed himself in the study of spectral lines, the mysterious patterns of light emitted by atoms. These patterns, which seemed random at first glance, contained deep mathematical order. Heisenberg suspected that understanding them might unlock the secrets of quantum behavior. But the calculations were daunting, the equations tangled and uncertain still. He persisted, driven by intuition and an unshakable sense that the truth was close. Heisenberg's restless curiosity led him to one of the most important figures in his life, Niels Bohr. In 1924, Heisenberg traveled to Copenhagen to work with Bohr at his Institute for Theoretical Physics. Bohr was already a towering figure, the architect of the atomic model and one of the leading minds of the quantum revolution. For Heisenberg, meeting Bohr was like meeting a living legend. But what began as mentorship soon evolved into a deep and sometimes tense collaboration that would shape the course of modern science. Bohr and Heisenberg were very different in temperament. Bohr was philosophical, patient, and contemplative. He liked to think in terms of ideas, analogies, and interpretations. Heisenberg, on the other hand, was direct, mathematical, and driven by intuition. Their discussions would stretch late into the night, sometimes calm, sometimes heated, but always profound. They were two minds trying to translate the language of the universe into human understanding. During those long nights in Copenhagen, Heisenberg's thoughts began to take a radical turn. He started questioning whether the traditional concept of an electron's path even made sense in the quantum world. The more he tried to visualize it, the more contradictions arose. Perhaps, he thought, it was not the particles themselves that were uncertain, but our way of describing them. These were the seeds of the revolutionary idea that would later define his legacy. But at that moment, Heisenberg was still searching, still a young man wrestling with the mysteries of existence. In the summer of 1925, exhausted from work and struggling with allergies, Heisenberg retreated to the small, wind-swept island of Helgoland in the North Sea. There, away from the distractions of the world, he sought clarity. He spent his days walking along the rocky cliffs and his nights under the stars, thinking about the strange patterns of atomic behavior. One night, as the wind howled outside his small cabin, the pieces suddenly came together in his mind. He realized that instead of trying to describe what electrons were doing, he could describe only what could be observed. The measurable quantities, the frequencies and intensities of spectral lines, were all that mattered. Everything else, he thought, was unnecessary speculation. From that insight, he built a new framework, a bold mathematical system that became the foundation of quantum mechanics. He called it matrix mechanics. It was abstract, complex, and unlike anything that had come before. But it worked. When Heisenberg sent his paper to Max Born, his mentor recognized it instantly as a breakthrough. For the first time, physics had a tool to describe the atomic world without relying on classical concepts of position and trajectory. Heisenberg was only 24 years old. That moment marked the true transformation of the curious student into a world-changing scientist. His idea would soon evolve into the uncertainty principle, the cornerstone of quantum mechanics and one of the most profound insights in human history. But on that lonely island, under the silent watch of the stars, he was still just a young man following the thread of curiosity that had guided him since childhood. The boy who once gazed at the night sky now held the keys to understanding its deepest mysteries. His journey, from a student of numbers and music to a master of the quantum world, was far from over. Yet even then, he sensed that his discovery was not merely scientific, but philosophical. It was a message from the universe itself that knowledge has limits, and that within those limits lies an infinite sea of possibility. As Heisenberg's academic journey deepened, so did his encounters with the brilliant minds that defined early 20th century physics. At Göttingen University, he met Max Born, a teacher whose enthusiasm for the new wave of quantum thinking ignited Heisenberg's imagination even further. Born was among the few who believed that the mysteries of atoms required a new kind of mathematics, one that went beyond the comfortable limits of classical theory. Under Born's mentorship, Heisenberg began to grasp the scale of the revolution that awaited science. It was not about adjusting the old rules, it was about rewriting them completely. Heisenberg's approach was different from many of his contemporaries. While others were fascinated by theoretical elegance, he was obsessed with what could be observed. He questioned the very foundation of physical reality, asking whether the unseen parts of the atom even existed in the way people imagined. This mindset brought him into contact with another great mind, Niels Bohr, the Danish physicist whose model of the atom had reshaped the early atomic picture. Bohr's Institute for Theoretical Physics in Copenhagen became the intellectual hub for the brightest minds of the era. When Heisenberg arrived there, he found not just a mentor, but a place where thought itself felt alive, where questions mattered more than answers. Bohr's teaching style was unlike anything Heisenberg had experienced. He would pose paradoxical questions, forcing his students to think beyond conventional logic. Heisenberg thrived in that environment. He admired Bohr's ability to merge philosophical thought with scientific precision. Yet their relationship was not without tension. Bohr was deeply analytical, preferring to interpret every idea through discussion and refinement, while Heisenberg's mind was restless, driven by intuition and bursts of insight. Their debates often extended late into the night, shaping some of the most important ideas in quantum theory. By 1925, the world of physics stood in chaos. The classical model, which had explained planetary motion and electromagnetism, failed miserably when applied to the quantum scale. Electrons didn't move in neat orbits like planets around the sun. They behaved unpredictably, jumping between energy levels in ways that defied Newtonian understanding. Heisenberg decided to tackle this mystery by focusing only on what could be measured. In a daring move, he ignored the concept of electron orbits entirely and built a mathematical framework based purely on observable quantities, such as the frequencies and intensities of spectral lines. This radical approach gave birth to what became known as matrix mechanics, the first consistent formulation of quantum mechanics. Heisenberg's paper, written while he was suffering from hay fever on the isolated island of Helgoland, marked one of the most significant intellectual leaps in the history of science. He had created a new language to describe the subatomic world, one that replaced the smooth predictability of classical equations with arrays of probabilities and uncertainties. At the time, even Heisenberg himself didn't fully grasp the revolutionary implications of his work, but Max Born quickly recognized it for what it was, a turning point that would change physics forever. Matrix mechanics defied visualization. It didn't describe where particles were or how they moved, only what could be observed about them. This abstraction frustrated many physicists, including Bohr at first, yet the mathematics worked perfectly. Suddenly, the chaotic behavior of atoms began to make sense, not as mechanical motion but as statistical behavior. Nature, it seemed, wasn't deterministic after all, it was probabilistic. Heisenberg's ideas soon spread across Europe, challenging scientists to rethink the nature of reality itself. Even Albert Einstein, who had laid the groundwork for quantum theory with his work on photons, was uncomfortable with where Heisenberg's reasoning led. Einstein famously declared, "God does not play dice with the universe." But Heisenberg's theory suggested otherwise, that the universe, at its core, was not governed by fixed laws but by probabilities. Despite opposition from some of the greatest minds of his time, Heisenberg continued to refine his ideas. His determination wasn't driven by pride or rebellion, but by a deep sense of wonder. He once described physics as an attempt to understand the harmony of the universe. For him, uncertainty wasn't chaos, it was the very fabric of existence, the melody of nature that humans were only beginning to hear. By the late 1920s, Heisenberg's fame had spread. At just 26 years old, he was awarded the Nobel Prize in Physics, a recognition that placed him among the giants of modern science. But even as the world celebrated him, Heisenberg remained humble. He understood that his discovery had opened a door to a deeper mystery, one that blurred the line between the observer and the observed, between knowledge and reality. In his later reflections, Heisenberg often compared the scientist's journey to that of an explorer crossing a dark ocean guided only by faint starlight. Each discovery, he said, illuminated a small patch of understanding, yet revealed vast new regions of ignorance beyond. This humility became the hallmark of his intellectual spirit. He believed that science was not just a tool to control nature, but a dialogue with it, a search for meaning in the patterns that lie beneath uncertainty. As Europe drifted toward the turbulence of the 1930s, Heisenberg's life, like his theories, became entwined with uncertainty. The rise of political conflict and the shadow of war tested his moral convictions. Yet even through those dark times, his devotion to science never wavered. His mind remained anchored in the quest to comprehend the quantum world, a world that refused to obey the logic of everyday experience, but revealed a profound beauty in its unpredictability. In every sense, Heisenberg's journey from a young student to a world-changing scientist mirrored the very essence of his discovery. He began in search of order and found instead a universe built on uncertainty. But within that uncertainty, he uncovered the deepest harmony of all, the realization that knowledge is not the end of mystery, but its beginning. Heisenberg's rise was not just a story of intellectual triumph, it was the story of human curiosity confronting the limits of understanding. It showed that even when reality seems uncertain, the pursuit of truth continues to move us forward. The same uncertainty that governs the dance of particles also defines the journey of the human spirit, ever searching, ever questioning, ever reaching toward the unknown, and thus through the restless curiosity of a young German physicist, the world entered a new era of thought, one where certainty gave way to possibility, and where the boundaries of knowledge expanded into the infinite quantum realm that still challenges and inspires us today. In the mid-1920s, the world of physics was in turmoil. The elegant laws that had once explained everything from the motion of planets to the swing of a pendulum were suddenly powerless when confronted with the strange and unpredictable behavior of atoms. Reality itself seemed to be falling apart under the microscope of quantum theory, and at the center of this scientific storm stood a young physicist named Werner Heisenberg, a man whose restless mind refused to accept confusion as defeat. Instead, he turned uncertainty into the foundation of a new reality. It was 1926, and Heisenberg was struggling with the contradictions between theory and observation. The newly developed quantum mechanics, his own matrix mechanics and Schrödinger's wave theory, both worked astonishingly well in predicting experimental results. Yet something fundamental was missing. How could two such different descriptions of nature, one based on discrete numbers and the other on continuous waves, both be correct? Heisenberg felt trapped between two incompatible views of reality. On one hand, the equations worked; on the other, they defied common sense. He withdrew from the chaos of academic debate and sought solitude in the small island of Helgoland, a place of sharp winds and isolation. There, surrounded by the calm sea and the whispers of nature, his mind began to untangle the paradox. He realized that the core problem was not in the mathematics, but in human expectation. Scientists were still trying to describe atomic behavior as if it obeyed the same rules as macroscopic objects. But the quantum world, Heisenberg realized, operated on principles of its own, principles that defied the certainty of classical measurement. As he thought deeply about this, a revelation began to take shape. He considered the act of measuring an electron's position. To see it, one had to illuminate it with light. But light itself was made of photons, and those photons would inevitably disturb the electron's motion. The very act of observing changed what was being observed. Heisenberg understood that this disturbance wasn't just a practical limitation. It was fundamental. It was nature's own rule. You could either know where a particle was or how fast it was moving, but never both at the same time, not with absolute precision. This simple but profound idea became known as the uncertainty principle. It stated that the more precisely you determine one property of a particle, such as its position, the less precisely you can know another complementary property, like its momentum. This was not a flaw in measurement or an imperfection of instruments. It was a basic feature of reality. Heisenberg's insight turned physics on its head. Until then, scientists had believed that the universe could be described completely if one only knew the position and velocity of every particle. This belief, rooted in the deterministic worldview of Newton and Laplace, gave humanity a comforting sense of control. It suggested that, in principle, the future could be predicted perfectly if the present was fully known. But Heisenberg's principle shattered that illusion forever. It said that nature does not allow perfect knowledge. There is a fundamental limit, a veil that cannot be lifted, no matter how precise our tools become. For many scientists, this was a deeply unsettling realization. It wasn't merely about measurement. It was about the nature of existence itself. If uncertainty was built into the structure of reality, then the universe was no longer a machine running like clockwork. It was a living symphony of probabilities, where outcomes could only be described in terms of likelihood, not certainty. Heisenberg presented his discovery to his mentor Niels Bohr, and together they refined its meaning. Bohr saw in it a reflection of his own principle of complementarity, the idea that particles can behave as both waves and discrete points, depending on how they are observed. The two principles together painted a picture of the quantum world as inherently dual and paradoxical. Reality was not fixed until it was observed, and even then, it could only be known partially. The implications were staggering. In a sense, Heisenberg had rewritten the relationship between the observer and nature. Observation was no longer passive. To observe was to participate, to alter the outcome by the very act of measurement. This idea blurred the boundary between subject and object, between mind and matter. It suggested that the universe was not an independent stage on which events unfolded, but a network of interactions where observation and existence were intertwined. As Heisenberg continued to refine his theory, he realized that uncertainty applied not only to electrons, but to all quantum systems. Every particle in the universe carried this built-in ambiguity. The more precisely you knew its position, the less precisely you could know its momentum, and vice versa. The same principle applied to energy and time. There was always a trade-off, a hidden balance that governed the quantum realm. This discovery was not just a scientific milestone, it was a philosophical earthquake. It forced humanity to confront the limits of knowledge and the illusion of absolute truth. For centuries, science had been a quest for certainty, to find the laws that would predict everything. Heisenberg's principle showed that this dream was impossible. The universe, at its most fundamental level, was not deterministic but probabilistic. It wasn't a clock ticking predictably, but a storm of possibilities unfolding moment by moment. Yet, despite its unsettling message, the uncertainty principle also revealed something beautiful. It showed that uncertainty is not chaos, it is the language of nature's creativity. Without uncertainty, there could be no change, no evolution, no life. The fluctuations that make the quantum world unpredictable are the same forces that give rise to the richness of the universe. Heisenberg's principle didn't destroy order, it redefined it, showing that the universe's harmony lies not in rigid predictability but in dynamic balance. As Heisenberg's work spread, scientists began to apply his principle to all areas of physics. It became the cornerstone of quantum mechanics, influencing everything from atomic structure to nuclear physics. It also inspired generations of thinkers to explore the deeper meaning of reality. Philosophers, theologians, and artists found in Heisenberg's uncertainty a metaphor for the human condition. The idea that knowledge is always incomplete, and that the quest for truth is an endless journey. For Heisenberg himself, the discovery was both a triumph and a source of profound reflection. He often spoke of the emotional impact it had on him. He realized that by uncovering the limits of knowledge, he had revealed something deeply human, the fragility of certainty and the beauty of mystery. In later years, he compared his insight to standing at the edge of a vast ocean, aware that no matter how far one sails, the horizon will always move farther away. In laboratories across the world, experiments soon confirmed his principle with astonishing precision. Every attempt to pin down a particle's position more accurately resulted in greater uncertainty in its motion. It wasn't just theory, it was reality itself. The uncertainty principle had become one of the most tested and verified ideas in all of science, and yet its philosophical echoes still challenge human understanding. Heisenberg's discovery transformed physics from a science of certainty into a science of possibility. It opened the door to new technologies, from semiconductors to quantum computers, and it forever altered how humanity perceives the world. But perhaps its greatest legacy lies in its message that knowledge and mystery are not enemies, but partners. To understand the universe, one must accept uncertainty, not as a failure of reason, but as the essence of truth itself. Through his uncertainty principle, Heisenberg did more than describe the quantum world. He gave voice to its poetry. He showed that the smallest things in existence, the particles invisible to the naked eye, carry within them the profound mystery of being. And in doing so, he reminded us that the quest for knowledge is not about eliminating uncertainty, but about learning to live within it, to see in it the delicate pulse of reality itself. As the world began to absorb the implications of Heisenberg's discovery, a silent revolution unfolded within the hearts and minds of scientists everywhere. The uncertainty principle was not just another addition to the library of physics, it was a challenge to the very philosophy that had guided human thought for centuries. It forced scientists, philosophers, and thinkers alike to confront a startling truth, that reality, at its deepest level, might not be something fixed and definite, but something fluid, relational, and alive. In the grand halls of academia, Heisenberg's idea sparked heated debates. Some physicists refused to accept that nature could be inherently uncertain. To them, uncertainty meant ignorance, a temporary flaw that better tools or sharper minds could overcome. But Heisenberg insisted that his principle was not a limitation of human perception, it was a law of the universe. The world, he said, was not an open book waiting to be read with perfect clarity. It was a symphony of probabilities, where each observation changed the music itself. Albert Einstein, though a pioneer of quantum theory himself, struggled deeply with this conclusion. He admired Heisenberg's genius, but could not accept a universe governed by chance. God does not play dice, Einstein famously remarked, expressing his belief that there must exist hidden variables, unseen laws that restore order beneath quantum unpredictability. Yet Heisenberg, joined by Niels Bohr, stood firm. They argued that such hidden determinism was unnecessary and perhaps even meaningless. The uncertainty was not a flaw to be fixed, it was a feature to be understood. The debates between these towering minds defined an era. Their discussions, sometimes friendly and sometimes fierce, stretched late into the night at conferences and private gatherings. Einstein would propose thought experiments to expose what he saw as contradictions in quantum theory, and Bohr, often with Heisenberg's quiet support, would counter each one with remarkable clarity. Through these intellectual battles, physics matured, not by erasing uncertainty, but by learning to embrace it. In time, experimental evidence silenced most doubts. The double-slit experiment, the photoelectric effect, and countless others revealed the undeniable truth. Particles do not have definite positions or velocities until they are measured. Before observation, they exist only as waves of probability, mathematical descriptions of what could be, rather than what is. When observed, these waves collapse into a specific outcome, as if nature itself makes a choice in response to the observer's question. This revelation extended beyond physics into philosophy. The act of observation became central, not only to measurement, but to existence itself. The boundary between observer and observed began to blur. Were we discovering reality, or were we, in some subtle way, participating in its creation? Heisenberg did not claim that consciousness alone shaped the universe, but his work opened the door to this profound question. It reminded humanity that science is not detached from the human experience. It is a dialogue between mind and nature, between question and response. The uncertainty principle also transformed how scientists viewed causality, the idea that every effect has a specific cause. In classical physics, this relationship was absolute. If you knew all the conditions, you could predict the outcome perfectly. But in quantum physics, causality became softer, more probabilistic. You could no longer predict exactly when an atom would decay or where an electron would appear. You could only describe the range of possibilities. The universe, it seemed, allowed freedom within its laws, a balance between order and spontaneity, between structure and surprise. For Heisenberg, this was not a source of frustration but of awe. He saw in uncertainty a reflection of nature's depth and creativity. In his writings, he often spoke of the connection between physics and philosophy, between science and spirituality. To him, understanding the world meant understanding its limits, and within those limits lay the beauty of existence. He once wrote, "The more precisely we determine our position, the less certain we are about our momentum. The more we define the present, the less we know of the future." In those lines lay not only a scientific truth, but a poetic vision of life itself. During his years at the University of Leipzig, Heisenberg became a mentor to a new generation of physicists who would carry his ideas forward. His lectures were not merely technical lessons but philosophical explorations. He urged his students to see beyond numbers and equations, to perceive the living essence behind the symbols. For him, physics was not a cold description of matter, it was a language that expressed the unity of the cosmos. He believed that the mathematical structure of quantum mechanics hinted at something profound. A hidden order that transcended human understanding, an order that existed not in certainty but in harmony. As the 1930s unfolded, Heisenberg's principle found applications across the expanding landscape of modern physics. It explained why electrons form stable orbits around atomic nuclei, why atoms bond to create molecules, and why stars burn in balanced cycles of fusion and energy. It became the invisible hand that guided the architecture of the universe. Every discovery that followed, from nuclear energy to quantum electronics, rested, in some way, on the foundation Heisenberg had built. Yet, as his scientific fame grew, Heisenberg also wrestled with the moral and philosophical implications of his discovery. The same quantum understanding that explained the stability of matter also led to the development of technologies capable of unimaginable destruction. The rise of nuclear research during World War II cast a dark shadow over the scientific community. Heisenberg, caught in the political turmoil of his time, found himself questioning the purpose of knowledge. Could science, born from the pursuit of truth, remain pure when used as a tool of power? This inner conflict haunted him for years, reflecting the very uncertainty he had discovered in nature. Even in the midst of these personal struggles, Heisenberg continued to defend the philosophical meaning of his principle. He believed that uncertainty was not a sign of chaos, but a bridge to deeper understanding. To him, it symbolized the humility of science, the recognition that human reason, though powerful, has its limits, and within those limits, there lies a profound connection between knowledge and mystery. He often compared the scientist's journey to that of a musician interpreting a symphony. The notes are written, but their meaning comes alive only in performance, in interaction, in uncertainty. In the decades that followed, the uncertainty principle became more than a law of physics. It became a metaphor for the modern age. It influenced art, literature, and philosophy, inspiring new ways of thinking about perception, truth, and existence. Writers and poets saw in Heisenberg's discovery a reflection of human experience. The idea that life itself is uncertain, that meaning is found not in rigid answers, but in the endless search for understanding. Even today, nearly a century later, the uncertainty principle continues to challenge and inspire. In the laboratories of quantum computing, scientists manipulate particles according to the very probabilities Heisenberg described. In cosmology, his principle helps explain the fluctuations that gave rise to galaxies and stars, and in philosophy, it remains a timeless reminder that reality is not a static picture but a living process, unfolding moment by moment in the interplay between knowledge and mystery. As Heisenberg grew older, he often reflected on his life's work with a quiet sense of wonder. He understood that his principle had not simply described the world, it had transformed how humanity sees it. He once remarked that the path to truth lies not in the conquest of uncertainty, but in the acceptance of it. For him, uncertainty was not an obstacle but a teacher, a gentle whisper from the universe reminding us that perfection lies not in control, but in understanding our place within the grand, unpredictable dance of existence. In the end, the uncertainty principle stands as both a scientific triumph and a spiritual revelation. It tells us that the universe, in all its vastness, is not a clockwork machine, but a dynamic tapestry of potentialities. It reminds us that our knowledge, no matter how advanced, will always be incomplete. Yet that incompleteness is what gives life its meaning. Through Heisenberg's insight, humanity learned that to observe is to engage, to know is to question, and to seek certainty is to misunderstand the beauty of the unknown. His principle endures not only in equations and experiments, but in the hearts of those who dare to wonder. Those who, like Heisenberg, look into the mysteries of existence and find, within uncertainty itself, the essence of truth. The birth of Heisenberg's theory marked not only a new chapter in physics, but a complete transformation in how humanity perceived reality itself. Before his discovery, scientists believed the universe functioned like a perfect machine, predictable and absolute in its behavior. Every event, it was thought, followed from a precise cause, and with enough information, one could predict the future with certainty. But when Heisenberg introduced his uncertainty principle, this vision of a mechanical and deterministic universe began to crumble. Suddenly, the smallest pieces of nature, the very atoms that compose all matter, refused to obey the rules that had guided science for centuries. Heisenberg's idea revealed a deeper, more mysterious world beneath the surface of reality. It showed that at the quantum level, objects do not exist in fixed states until they are observed. An electron could not be said to be in one place or another, but rather in a cloud of possibilities, a blur of potential locations and energies. Reality, it turned out, was not a solid structure but a field of probabilities, constantly shifting and only becoming definite when interaction occurred. The universe, as Heisenberg saw it, was no longer a static picture but a living, evolving process. This revelation forced humanity to reconsider what it meant to know something. In classical science, observation was seen as neutral, a way to gather information about a world that existed independently of us. But in the quantum world, the act of observing became inseparable from the thing being observed. To measure a particle's position or momentum was to disturb it, to participate in shaping its outcome. Heisenberg's theory implied that reality was not an independent stage upon which events unfolded, rather, it was a dialogue between the observer and the observed. The universe responded to attention. Existence itself was relational. This shift was not easy to accept. Many great minds of the era, including Einstein, resisted the idea that chance and uncertainty lay at the heart of nature. Yet experiment after experiment confirmed it. Particles behaved like waves until measured, and only upon observation did they take on specific forms. Reality was not fixed, it was fluid, conditional, and deeply mysterious. For philosophers, this discovery blurred the boundary between science and metaphysics. It echoed ancient ideas that perception shapes reality, that knowledge and being are intertwined. But now these ideas had emerged from the core of modern physics itself. Heisenberg's redefinition of reality went beyond laboratories and equations. It changed how people thought about the universe and their place within it. The material world was no longer an assembly of rigid objects, but a web of energy and interaction where everything influenced everything else. The observer, once seen as separate from nature, became part of the very fabric of reality. This understanding dissolved the illusion of isolation. It suggested that consciousness and matter were connected in ways yet to be understood, that the universe might be less like a machine and more like a conversation between energy, matter, and awareness. In redefining reality, Heisenberg also redefined certainty. The world he showed was not built upon unshakable truths but upon delicate balances and probabilities. Each measurement, each observation, revealed only one face of a deeper whole. What we call reality, therefore, is not the ultimate truth, but a projection of what we can measure and perceive. The quantum world hides infinite possibilities beneath every observed moment, and every act of measurement collapses those possibilities into one tangible event. Thus, existence becomes a continuous act of creation, dynamic, uncertain, and endlessly unfolding. Heisenberg's insight reached far beyond physics. It touched the foundations of philosophy, inspiring thinkers to revisit the relationship between knowledge and perception, between objectivity and participation. It resonated with artists and writers who saw in his principle a reflection of human experience. How our understanding of life, too, is shaped by perspective, emotion, and choice. The rigid lines that once divided science and art, matter and mind, began to soften. The universe appeared not as an indifferent mechanism, but as an interconnected web of meaning. In the decades that followed, the implications of Heisenberg's redefined reality continued to expand. Quantum mechanics, built upon his principle, became the foundation of modern technology, lasers, transistors, and even computers. Yet the philosophical impact was equally profound. Humanity was forced to accept that absolute certainty might be an illusion, that truth was not a fixed point, but a spectrum of possibilities. This realization, far from diminishing the power of science, made it more humble and more profound. It reminded us that knowledge is not about conquering mystery, but about living within it. Heisenberg's theory ultimately changed how we perceive existence itself. It taught us that beneath the apparent order of the world lies a realm of potential, a space where every moment is a dance between the known and the unknown. Reality is not something we merely observe, it is something we help create through observation, interaction, and intention. In this way, Heisenberg reconnected humanity with the wonder of being, showing that uncertainty is not the end of knowledge but its beginning. The universe, once thought to be mechanical and predictable, was revealed as something far greater, a living mystery, where certainty dissolves and imagination becomes a path to truth. In the aftermath of Heisenberg's groundbreaking revelation, the scientific world was left to grapple with a question that reached far beyond mathematics or physics. What does it mean if reality itself is uncertain? The uncertainty principle had not only changed the way scientists studied the atom, it had shaken the very foundation of human understanding. For centuries, science had promised that with enough observation and calculation, the mysteries of nature could be completely unlocked. But Heisenberg's theory introduced a limit, an invisible boundary that even the most brilliant minds could not cross. It declared that there is a fundamental blur at the heart of existence, a space where knowledge dissolves into probability. This realization was both terrifying and liberating. It meant that the universe was not a rigid clockwork mechanism, but something more alive, unpredictable, and creative. Heisenberg's work invited a new way of seeing the world, one that embraced mystery as part of reality rather than as a flaw in our understanding. In the laboratories of the early 20th century, physicists began to look at atoms not as tiny solid spheres but as waves of possibility, existing in multiple states at once. The notion that matter could be both particle and wave defied human logic, yet it fit perfectly with the results of experiments. What Heisenberg revealed was that certainty was not the true nature of the universe. Uncertainty was. This idea changed how scientists approached not only physics but also philosophy, as they began to see that reality was something far more dynamic and interactive than anyone had imagined. The uncertainty principle soon became a symbol of a deeper truth, that our human quest for absolute control and knowledge might always meet limits. Even Einstein, one of the greatest minds in history, struggled with this new vision of the cosmos. He famously said, "God does not play dice," expressing his discomfort with the randomness implied by quantum theory. But Heisenberg stood firm. To him, uncertainty was not randomness, it was nature's way of preserving freedom and complexity. The more deeply scientists looked into the fabric of reality, the more they realized that the universe was not ruled by strict laws of determinism, but by patterns of probability and chance. The beauty of nature lay not in its predictability, but in its endless capacity for surprise. This transformation in scientific thought led to technological revolutions that would define the modern world. Quantum mechanics, which grew out of Heisenberg's principle, became the foundation for countless inventions: semiconductors, lasers, transistors, and the very computers that now shape our daily lives. The irony was profound. From the recognition of uncertainty came the tools that gave humanity unprecedented control over technology and information. It was as if by accepting the limits of knowledge, science had opened new doors of power and creativity. Heisenberg's principle had not closed the path of discovery, it had expanded it infinitely. Beyond laboratories and equations, Heisenberg's vision carried spiritual and philosophical weight. It suggested that the universe was not a separate, indifferent system, but something intimately connected to the observer. Every observation, every act of measurement, shaped the world in some way. This idea resonated with ancient wisdom and modern thought alike, blurring the line between physics and metaphysics. Reality, it seemed, was participatory, a dance between consciousness and matter. The more we observed, the more we influenced. In this sense, Heisenberg's theory reflected not just the structure of atoms, but the essence of existence itself. The world Heisenberg revealed was one where certainty could no longer serve as the foundation of truth. Instead, humanity had to learn to live with ambiguity, to accept that knowledge is always incomplete. This humility brought a new kind of wisdom, an understanding that life, like the quantum world, thrives in uncertainty. Every choice, every event, every heartbeat is a moment of possibility, collapsing into reality only when experienced. The uncertainty principle thus became more than a law of physics, it became a metaphor for existence. It told us that to be alive is to exist within the unknown, to embrace mystery as part of what makes life meaningful. As time went on, Heisenberg's ideas continued to echo through science, art, and philosophy. They challenged thinkers to see order within chaos and beauty within unpredictability. The uncertainty principle became a guiding light for a new age of exploration, one that looked inward as much as outward. In the end, Heisenberg's legacy was not merely a scientific equation, it was a revelation about the nature of reality and the human spirit. He showed that uncertainty is not a limitation, but the very heartbeat of creation, the silent rhythm through which the universe continues to unfold its endless mysteries. As the ripples of Heisenberg's uncertainty principle spread through the scientific world, its impact began to extend beyond laboratories and academic debates. It reached into philosophy, art, and even the human understanding of consciousness itself. The sixth key moment in this journey was not a single discovery, but the awakening of a profound realization that Heisenberg's vision had forever transformed humanity's relationship with knowledge and reality. The The quantum world had revealed that the universe was not a rigid, mechanical structure, but an ever-changing field of potential, alive, interconnected, and deeply mysterious. Heisenberg's ideas did not just change physics, they changed the way people thought about existence, perception, and the boundaries of human understanding. In the decades that followed his revelation, the uncertainty principle became a symbol of intellectual humility. It taught scientists that no matter how advanced their instruments or equations became, there would always be a limit to what could be known. But within this limitation lay beauty. For the first time, science openly embraced mystery as a natural part of reality, not as a flaw in observation. Heisenberg's theory told the world that uncertainty was not chaos, it was the creative fabric of existence itself. Everything that existed, from the stars in the sky to the particles in our bodies, was bound by the same delicate balance of probability. The universe was not fixed, it was a symphony of motion, where each note was shaped by unseen possibilities. This understanding began to influence how scientists approached the study of nature. Instead of searching for absolute answers, they began to explore relationships, interactions, and patterns. Quantum mechanics became a language for describing how reality behaves when certainty disappears. Heisenberg's insight showed that everything is connected, that particles communicate across space, and that reality itself is a web of energy and potential. The observer was no longer a passive witness, but an active participant in shaping the universe. Every act of observation became an act of creation, collapsing infinite possibilities into one tangible outcome. This was not only a scientific revelation, it was a philosophical awakening that blurred the line between science and spirituality. The effects of this new worldview soon spread into other disciplines. Philosophers began to question the nature of truth, artists explored uncertainty through abstract expression, and writers reflected the fluidity of reality in their works. The rigid boundaries between science and art began to dissolve, replaced by a shared recognition that all human understanding is a kind of interpretation, a snapshot of a universe that refuses to stay still. Heisenberg's theory reminded humanity that reality is more poetic than mechanical, more dynamic than static. Even technology, built upon quantum mechanics, carried this paradox within it. The computers, lasers, and electronics that define modern civilization all operate based on principles of uncertainty. But the deeper influence of Heisenberg's principle lay in its moral and philosophical implications. It forced humankind to confront its own limits, to realize that control and certainty are illusions. The world could no longer be seen as something to be mastered, but something to be understood through coexistence. Uncertainty became a symbol of freedom, a reminder that the future is not written, that possibilities remain open, and that creation continues in every moment. For many thinkers, this insight resonated with spiritual traditions that spoke of interconnectedness and the unity of all things. Heisenberg's science, grounded in mathematics, had unintentionally echoed the wisdom of ancient philosophies that saw life as a harmony between the known and the unknown. The human story, too, began to mirror this quantum truth. Just as particles exist in states of possibility, people live in worlds shaped by choices and perception. Each decision collapses countless outcomes into one reality. Each act of awareness defines what becomes real. The uncertainty principle thus became a metaphor for life itself, a reflection of how human existence is defined not by certainty, but by courage in the face of the unknown. It reminded humanity that the beauty of life lies not in having all the answers, but in exploring the endless questions. Heisenberg's legacy, therefore, is not confined to the pages of physics textbooks. It is alive in every field that seeks to understand the nature of being. It is present in the silence between musical notes, in the spaces between stars, and in the mysterious workings of the human mind. His discovery revealed that uncertainty is not something to fear, but something to embrace, for it is within uncertainty that creativity, progress, and consciousness itself arise. Through this realization, humanity learned to see the universe not as a puzzle to be solved, but as a living story, one that unfolds through participation, curiosity, and wonder. In the end, Heisenberg's principle did more than describe the quantum world. It offered a new way of thinking about existence. It taught that reality is not a final destination, but an ongoing process of discovery where observation, imagination, and mystery coexist. The deeper we look into the universe, the more we find ourselves reflected in it. Complex, uncertain, and full of potential. And perhaps that was Heisenberg's greatest gift, to remind us that uncertainty is not the end of knowledge, but the beginning of understanding, the spark that keeps both science and the human spirit alive. As the 20th century unfolded, Heisenberg's uncertainty principle grew beyond the boundaries of physics and entered the heart of human thought, philosophy, and imagination. It was no longer just a scientific formula, it had become a mirror reflecting the deepest truths about existence itself. The seventh and final keynote in this journey captures how Heisenberg's discovery reshaped humanity's understanding of life, consciousness, and the very nature of reality. His ideas inspired a new way of thinking, a realization that uncertainty is not a flaw of the universe but its essence, that unpredictability is not chaos but the rhythm through which creation unfolds. In every corner of science and thought, the echoes of Heisenberg's insight continue to resonate, reminding us that knowledge is a living process, and that truth is not found in absolute answers, but in the harmony between what is known and what remains unknown. Heisenberg's work revealed that the universe is a vast field of possibilities, constantly evolving through interaction and observation. Nothing exists in isolation. Every particle, every atom, every breath of air is connected through invisible threads of energy and probability. When Heisenberg proposed that one cannot precisely know both the position and momentum of a particle, he was also revealing something profound about existence, that reality itself is relational. What we perceive depends on how we look. The world does not exist as a finished painting, but as a work in progress, responding to our awareness and interpretation. This realization blurred the once clear line between observer and observed, science and philosophy, mind and matter. The legacy of this idea reached far beyond theoretical physics. It began to influence psychology, suggesting that perception itself shapes experience. In art, it inspired movements that celebrated abstraction and the fluidity of form. In philosophy, it opened new questions about free will, consciousness, and the limits of reason. Even in spirituality, Heisenberg's uncertainty found reflection, aligning with ancient teachings that spoke of the universe as a flowing, interconnected whole. Through this fusion of science and philosophy, the uncertainty principle became more than a scientific law. It became a symbol of a deeper truth, that reality is not fixed but alive, creative, and deeply mysterious. Over time, this understanding began to change the way humanity approached progress and discovery. Science was no longer seen as a tool to conquer nature, but as a partnership with it. The quest for absolute certainty gave way to curiosity, humility, and wonder. Heisenberg's discovery reminded scientists that every breakthrough reveals not the end of knowledge, but the doorway to new questions. The smallest particle in the universe was no longer a mere object. It was a storyteller, whispering of infinite possibilities hidden within the fabric of existence. Through this lens, even the most ordinary events of life became extraordinary. Every moment, every interaction, every thought was part of a larger, interconnected dance between energy and awareness. Heisenberg's vision also carried a quiet lesson for humanity itself. Just as no particle's future can be perfectly predicted, no human life can be fully controlled or foreseen. The same uncertainty that defines atoms defines the human journey. Each person moves through a universe of choices, where one decision, one act of observation, can alter the entire path ahead. This realization offered a kind of freedom, a reminder that the unknown is not an enemy, but the source of all growth and creativity. The uncertainty that governs the quantum world is the same uncertainty that allows love, art, discovery, and change to exist. Without it, there would be no evolution, no progress, no life. In the modern age, as technology built upon quantum mechanics reshapes the world through computing, communication, and artificial intelligence, Heisenberg's principle remains its silent foundation, yet beyond its practical impact lies its deeper gift, a new philosophy of being. It teaches that knowledge must walk hand in hand with mystery, that truth is not something we own, but something we participate in. To understand the universe is not to eliminate uncertainty, but to embrace it, to see it as the pulse of existence itself. Every act of observation, every question we ask, keeps the universe alive and unfolding. As time passes, the spirit of Heisenberg's discovery continues to inspire new generations of thinkers and dreamers. It reminds us that certainty can blind, but curiosity awakens. It calls humanity to explore not just the outer universe, but the inner one, to seek meaning not in control, but in connection. The uncertainty principle stands as a bridge between science and philosophy, showing that the smallest truths of nature can reveal the greatest truths of existence. It tells us that the world is not a static collection of facts, but a living conversation between energy, matter, and mind. And so, the story that began in a quiet German laboratory nearly a century ago continues to shape how we see ourselves and the cosmos. Werner Heisenberg's discovery did more than transform physics. It transformed the human spirit. It opened our eyes to a universe that is vibrant, mysterious, and full of possibility. It taught us that uncertainty is not the end of understanding, but its beginning, that in the vast unknown lies the beauty of creation itself. And perhaps that is the greatest legacy of all, the reminder that we, too, are part of that quantum mystery, forever changing and forever discovering, in a universe that invites us not to know it completely, but to marvel at its endless unfolding.